Example number 4. Use the given information to find the exact value of each of the following. A, sine 2 theta, B, cosine 2 theta, C, tan 2 theta. Given that cotangent of theta is 12 and theta lies in quadrant 3. So let's think about our signs before we do anything else. We're down here in quadrant 3. So here we have a cosine, which is negative, a sine, which is negative, a tangent, which is positive, meaning our cotangent is also positive. So for sine 2 theta, I'm going to use 2 sine theta cosine theta. For cosine 2 theta, I'm going to use cosine squared theta minus sine squared theta. And for tangent 2 theta, I'm going to use 2 tangent theta divided by 1 minus tangent squared theta. So I know that the cotangent is 12. So I'll draw a triangle here. Remember that cotangent of theta is adjacent over opposite. So just flip over the tangent. And we know that the cotangent of theta is 12. So they give us 12 over 1. So my adjacent to theta is 12, and my opposite is a 1. So I'll have to use the Pythagorean theorem to find this length of the hypotenuse. So 12 squared plus 1 squared is the hypotenuse squared. So that's 144 plus 1 is the hypotenuse squared. So the hypotenuse is the square root of 145. So this hypotenuse is irrational. There's no perfect square of 145. Now, it's possible that that could be reduced, but we'll just wait until the end to reduce. Okay? Now, remember, our cotangent is positive, our cosine is negative, and our sine is negative. So let's go ahead and so we'll do our cosine of theta, and we'll keep in mind that this is in the third quadrant, so cosine is going to be negative. It's going to be our adjacent divided by our hypotenuse. So it's negative 12 over the square root of 145. And I'll go ahead and reduce this, at least by getting the radical out of the denominator. Multiply the top and bottom by the square root of 145. So minus 12 times the square root of 145 over 145. And don't forget, it's a negative. Now my sine of theta is also a negative. And put a negative there. And my sine is my opposite, 1 over my hypotenuse, the square root of 145. And if I multiply again by the square root of 145 over the square root of 145, I get negative square root of 145 all over 145, and that can't be reduced. And now the tangent of theta. Well, the tangent of theta can be done by putting sine over cosine, but since we already know the cotangent is 12 over 1, our tangent is 1 over 12. So now we can do our double angles. So sine of 2 theta is 2 sine of theta, which is negative square root of 145. All that is over 145 times the cosine of theta, negative 12 square root of 145, and all of that is over 145. So I've got a 2 over 1. I've got a negative times a negative, which is a positive. And since we're multiplying two square roots, the root will be removed, 145. And I'm just going to go ahead and put the 145 times 145 down here so I can quickly reduce that 145 in the numerator. So my answer is going to be 2 over 145 for my sine of 2 theta. So my formula for cosine 2 theta is cosine square theta minus sine square theta. So cosine squared minus 12 square root of 145 over 145 squared minus sine theta, negative square root of 145 over 145 squared. So this is going to give me a negative 12 times a negative 12, which is 144. Square that square root, going to be 145. Remember, a square root times itself is going to remove the root. And in my denominator, I have a square, but I'm just going to write it out. 145 times 145, so I can see that I can reduce out one of the 145s. Now, I'm going to do the sine squared of theta, and I'm going to get a negative times a negative, which is also a positive, so squaring a square root, 145 over 145 times 145, because that's what I get when I square this denominator. And I can see that that will go into that, but I have to write my 1 in my numerator. So now I have to subtract these two fractions. 144 over 145 minus 1 over 145. 144 minus 1 is 143 over 145. And that's the answer for the cosine of 2 theta. And finally, we're going to do the tangent of 2 theta. I'll go ahead and remind you what the formula is. 2 tan theta, and all of that is over 1 minus tan square theta. So our tan 2 theta is 2 times 1/12 over 1 minus 1/12 squared. Well, that's 2 over 12 over 1 minus 1 squared is 1, 12 squared is 144. So a little cleanup here. 2/12. Remember, 1 is going to be 144 over 144. So I've got in my denominator 144 over 144 minus 1 over 144. That's going to give me 2/12 over 143 over 144. And obviously, I can't leave it like this. And so now I'm going to have to clean up this fraction. 2/12 divided by 143 over 144. So there are a couple of ways you can do this. I think the simplest way is just use fraction division. 2/12 divided by 143 over 144 is 2/12 times 144 over 143. And then I can take my 12 into 144 and leave a 12. And that will give me 24 in the numerator and 143 in the denominator. So my tangent of 2 theta is 24 over 143.